Okay, over to the right here, we have a table that's using Desmos to kind of confirm that the f of xy and g of xy represent the same values, no matter what the values of x and y are. Now, we might notice right away from the table that there's a problem when x is negative, because when x is negative, right here, we'll be taking the fourth root, an even root of a negative number, because a negative number raised to the fifth power is negative. You can't take an even root of a negative number. So that's why we get undefines on this row. It's okay to take or have a y value that's negative, because y raised to the fourth power will give us a positive number, and then it doesn't matter whether we're taking a fifth root or a fourth root. That number will still be defined. But notice that if I don't have these absolute value symbols around the x and the y, that h of xy gives me a negative number when f of x comma y gives me a positive number. That's why we have these absolute value symbols here. Because if I put a -2 in for y here and then square it, I'm going to be getting a positive, raise it to the fourth power, I'll get a positive number. And the fifth root and the fourth root of positive numbers are positive. But then if I put this xy outside the radical symbol, I'm going to get a negative number. That's why we have these absolute value symbols. Now, how do we get from the original problem to get it to look like this? There's a few ways to think about it. I like to just convert everything to a rational exponent. So the fifth root of something is the same as raising it to the 1/5. The fourth root, same as raising it to the 1/4. Then I use like the third property of exponents, a power of a power. I multiply these exponents. So this becomes x to the 3/5, y to the 4/5. I change the order here. And x to the 5/4, y to the 1st. Now, if I want to actually get these under the same radical symbol, I need a common denominator. So I convert the 3/5 and the 5/4 to 20ths, common denominator. And this y to the 4/5, I'll convert to 20ths also. And of course, y to the 1st is just y. Now I can add these exponents, y to the x to the 37/20ths, y to the 16/20ths. And now if I'm taking the 20th root of x to the 37th, like this is what you're visualizing. The 20th root of x to the 37th is the same as x to the 17th times x to the 20th. The 20th root of x to the 20th is 1. That's why I got this. So I kind of pictured separating those into x to the 17th times x to the 20th. 20th root of x to the 20th is x to the 1st. And now these two factors right here, or these two powers, have the same root index, same denominator, 20. So I can take the 20th root of x to the 17th, y to the 16th, put the xy out front, but to make sure that they're representing the same values as the original function, I need absolute value symbols right there. Okay, now your textbook might not go into that much detail with the absolute value symbols. Some textbooks assume that x and y represent positive numbers so that you don't run into that situation. But there you go. Hope that helped. If you have any questions, post a comment.